Right, 2010 question 9. So study the reaction scheme and answer the questions that follow. Name the molecule in the scheme that has no tetrahedral carbons. As I always say in these, draw them out. So the first one is C2H5OH. I see that there is ethanol. No tetrahedral, or all tetrahedral carbons in that. Your next one there is C2H4. That's my ethane. Now this is actually the molecule. Name the molecule in the scheme that contains no tetrahedral carbons. I'll come back to that. I'll draw the other ones. C2H5Cl. Again, all tetrahedral carbons. And then your last one, C2H6. Ethane. Single bond saturated substitution. So the first one there, name the molecule that has no tetrahedral carbons. It's this one up here. It says name, so it's ethane, or C2H4. Identify an addition reaction. So alkenes always react by addition. So if you look at those which are coming out of your addition mechanisms is V, Y and W. So B part 1, addition, it's either V, all alkenes react by addition. V, Y, or in some sense you could say W there because alkenes are undergoing addition reaction with themselves. A substitution reaction, when I think of substitution, I'm thinking of alkenes. Alkenes always react by substitution. So I've got my C2H6 down the bottom, it's going to C2H5Cl, so it must be my Z. Describe the mechanism of Y. So Y, once again, we did it in a previous question there, is my C2H4. I'm just going to just flick back a page because that's literally where it is. C2H5Cl, but hey, I'll make use to it. This is the addition. What did I add on? I added on HCl because you can add straight across the double bond, the electron-rich double bond. So I'll just draw the pictures again. You can put in the words. So this is your ionic addition mechanism. So you've got your C2H4 molecule. Your HCl approaches it there at a right angle. It doesn't induce polarity because it already is polarized because there's an electronegativity difference. Your hydrogen has a smaller value compared to your chlorine. Your plus always does the attacking. So your next step in that, your hydrogen goes straight on. Now when that hydrogen goes straight on, it draws the electrons away from that carbon there and it forms what's known as a carbonium ion. And you've got your Cl minus floating about. Next step, I didn't do it the last time, I'll do it this time. My Cl minus is just going to swoop in from the opposite side. And then this results in the formation of my product 1,2-dichloroethane. Oh, sorry, chloroethane. I can't multitask. So describe the mechanism of Y. Next thing, D. Rattling through this. State the reagent and conditions required to bring about V. Now V is C2H4 to C2H6. So all I've simply done, this is an alkene. Alkenes react by addition. What have I added on? I've added on hydrogen. And anytime I add on hydrogen, I use a nickel catalyst. Same in the reduction from CAP. So the reversal PAC or KS, ketones to secondary alcohols. And the next one, conversion Z. So what is conversion Z? C2H6 to C2H5Cl. Now C2H6, it's an alkane. Alkanes always react by substitution. Think of my free radical substitution. So it's chlorine and the condition there is UV light. Draw a lab diagram to show how conversion X can be carried out. Conversion X is just my C2H5OH into my C2H4. So this is the preparation of ethanol from ethane. Again, I've just done a page back, but it doesn't take too long. My bow. Beehive shelf, as I always do a graduate cylinder here, just getting the good habits for measuring rates. My basin, or my trough, some of you might say, of water. It's non-polar, collected by displacement of water. So there's my glass wool, soaked in ethanol, holds it in place. Bunsen burner below my dehydrating agent, which is Al2O3, aluminium oxide. I've got my ethane being collected up here by displacement of water, as it's non-polar, your van der Waals forces in your beehive shelf. Now don't draw their picture any smaller than that. And F, conversion W. So W there is going from ethane to PVC, so polychloroethane, polymerization reaction. 3 step synthesis, draw the structures of the 2 organic intermediates. Now I'm just going to draw that quickly. One of them there, you firstly add on chlorine to get 1,2-dichloroethane. It's always hard to remember. So that's going to just bring in a chlorine molecule onto it first of all. And then what do? You do thermal cracking and you remove a HCl. You form chloroethane. And then that's what undergoes addition with itself to form PVC polychloroethane. So I'm obsessed with 1,2-dichloroethane today. And then your last one there, 2009, question 8. So, give the UPAC name of each of the compounds A to D. Now, as I always say, draw them out. So A is C2H5OH. Because even if they ask you what bonds are broken or what bonds are formed, you have it. When you see that, you've got your OH group. So it's an alcohol, 2 carbons, ethanol. Your next one, B, CH3CHO. So CH3, C double bond O, H. The carbonyl group at the end, it's an aldehyde, metheth, ethanol, isomers of ketones. CH3, COH. So draw it as you see it from left to right. 2 carbons, so it's eth. It's got your COH, so it's ethanoic acid. And then your D, CH3, C double bond O, O, C2H5. So this is an ester. A wee bit more work in naming the brute. So start down here, C2H5, it's an ethyl. And then up here, 2 carbons as well, ethyl ethanoate. Name the family of organic compounds to which compound B belongs. So compound B, set up there, ethanol belongs to aldehydes, alcohol dehydration, your PAC. And name the aromatic compound found in almond kernels that is the same functional group as B. So I've got my CHO functional group, Now, the key word there is aromatic. Now, once it says aromatic, you know it's got this benzene ring. So it's got the same functional group as that. So this is known as benzaldehyde. You'll know it from your phenylmethanol to benzoic acid. You might get a smell of almonds throughout. Now, if they did ask you for the molecular formula of that, benzene's normally C6H6. If it's got any group attached on, your hydrogen reduces. So it becomes C6H5 as there's one group, CHO. Now, all they're looking for is the name. But the more you know, the better. What are we looking at now? C. Which of the compounds is present in concentrations in whiskey? So that was my ethanol. Ethanol is the alcohol that we consume. So ethanol, or C2H5OH, or B, whatever you wanted to call it there. And which of the other compounds is formed as a metabolite of this compound in the human body? So this is just when it's broken down. So I'm thinking of my PAC. So my primary alcohol gets oxidized by oxygen in the air to your aldehyde, which we have in that list. And it goes to ethanol. Or your C. Or B, sorry. So up here must have been my A. D. Describe what is observed when a small amount of sodium carbonate is added to a solution containing C. Now C, as we said over there, is ethanoic acid. This is sodium carbonate. Now this is just your general reaction. I'll slow down a wee bit here. An acid and a carbonate. What's my three products when I react an acid and a carbonate? I get a salt plus water, and this is what we're going to observe, carbon dioxide. Now when we get carbon dioxide produced or evolved, what do we notice? We see bubbling, we see fizzing, effervescence, they like that one, like your vitamin C tablets. Write a balanced equation for this reaction. So my acid there is CH3COH. My carbonate is sodium carbonate. So my salt, what's a salt? Salt is a compound obtained when the hydrogen of an acid is replaced by my metal. That's my alkali metal, my group 1. Now both of those have a valency of 1, or 1 hook. So we'll go straight in. So we get CH3, that can be difficult. CONA plus water plus carbon dioxide. Is that balanced? No, it's not. So you've got 2 NAs there. You have 2 here, so stick a 2 in front of that. And now I've doubled that CH3COO, 2 in front of that. Your hydrogen's been doubled with your H2O. You could check all that, but I know that's right. There's a lot going on in this. That's my first observation. That's my balanced equation. I always wish they labelled parts. Part 3, name the flavouring agent that contains 1 molar solution of C, so a 1 molar solution of ethanoic acid. The flavouring agent there is vinegar. And express the concentration of a 1 molar solution. So 1 molar means 1 in the big M. CH3COH. Nice wee one, wee maths one. I gotta go percentage weight per volume. Now that percentage means in 100. So how many grams in 100 centimeters cubed? So the first thing, work with the big M. The big M means the number of moles in a litre. I want to go from moles to grams. Think of my mole triangle. How do I go from moles to grams? I multiply by the relative molecular mass. So I need to work out the relative molecular mass of ethanoic acid. So 2 carbons, 2 by 12, 24. 4 hydrogens, 4 by 1 is 4, and 2 oxygens, 2 16ths, 32. You add them up, you get 60. So you're going to multiply your 1 mole per litre by 60, gives you 60 grams per litre. We want to get the number of grams in 100 centimetres cubed. Just remember 1 litre is 1000 centimetres cubed. So you could just simply divide that by 10. Or you can say 60 in 1000. To make anything a percent, multiply by 100. Get you 6 grams in 100 centimetres cubed. Therefore 6% weight per volume. That's a long-winded way to do it. But you take your time and you get it right. So that's 6%. Sun's kind of shining in and out a wee bit. And draw the full structural formula for D. I've actually done it over here. And to save me taking on a new page, I'll just do it over here. And label each carbon atom that is tetrahedral geometry. So tetrahedral single bonds. So there's tetrahedral. Now make sure you do your individual parts. You do it down here like a part E. That's a tetrahedral carbon there. And that's a tetrahedral there. This one's not, it's planar.